So we have with us Vijay Ganti. Please come on, Vijay. Vijay is going to talk about how AI is playing a role in the security, enabling this journey similar to everybody drives, a lot of people drive, I don't drive, but autonomous vehicles. So it's analogous to like self-driving car adoption. That's the way the role of AI is evolving. A brief intro about Vijay, and then I'll have Vijay take the floor. Vijay is the Director of Product Management at Google, and his team focuses on building products that drive transformation of cyber threat intelligence operations and security operations by using modern tech stack using AI. Before Google, Vijay headed the product management at VMware for the security business unit and also headed the AI ML research teams as well. And Vijay has almost 10 plus patents, many more, and they are all at the intersection of AI, ML, and security. So with that, Vijay, please take it over.
Thank you. Thank you. I wonder what's more important, food or food for thought? So I think we know the answer. Data, that's a good one. I was actually on the same stage in 2018, and I was moderating a panel of industry experts. And I'd asked them a simple question: what's your prediction for AI in security? Because that was the topic, even in 2018. It was Ram Varadarajan. He's the founder, CEO of Deception Technology. Amit Sinha, he was president, CTO, co-founder for Zscaler. And Mei Wang, I think she was founder, CTO for Zingbox, which was acquired by Palo Alto. So very illustrious set of people. Predictions are hard, especially about future. And so it's interesting what they said. I want to see, did these predictions age better than I have aged? And I think they did. Ram said that expect to have autonomous AI in one of your companies in your neighborhood, right? Expect that in 3 to 5 years. So I think that's probably coming true. May has said that every security company will actually have a working AI product, not an AI product, but a working AI product. And what Amit said was that security operations is right now flooded with alerts. AI will be the panacea which will help security operations team manage these alerts. I think all of them were right. You can argue that was their timing right? I don't think we achieved that in 3 years since 2018. But post-2022, I think we're getting there. So with that, let me just get started. So this is a TLDR slide. What was true yesterday about AI and security? Very quickly, the impact was marginal from 2010 to 2022. If you forget everything else, just remember the TLDR slide. We had few very narrow use cases that were using classical AI. When I say classical AI, I say everything before Gen AI or ChatGPT or Gemini, right? If you look at today, we have horizontal use cases in security, and I'll show you some of those, that have broad applicability. And because they're broadly applicable across security stack, the impact is a significant one, but it's like an augmentation. It augments the human being. So if you're thinking autonomous driving, then from L1 to L5 level of autonomous nature, think about this as L2 and L3 level of automation, okay? Tomorrow, we fully expect high degree of autonomous security. This is like L4, L5 level, if you're again referring to self-driving car analogy. And we will achieve that through Gen AI, but post-Gen AI as well. Things that are getting invented now will be a key contributor to that. At that point in time, we fully expect it to be a human override and oversight mode only. Okay? So that's the trajectory that we expect. With that, let's cover yesterday. Why was yesterday so bad? First of all, the use cases were very, very narrow. For those of you who've been around for a while, like me, next generation antivirus was probably one of the first significant use of machine learning. There's a company called Silence, which actually revolutionized this a little bit. but then it faded, right? And then the second category, largely that where ML was used, is the anomaly detection, which is largely semi-supervised or unsupervised machine learning. The problem with anomaly detection is that the intersection of anomaly and maliciousness is very small. So if you apply it broadly, you get a lot of noise. But there are subdomains within security where this works well. So that was very well used, right? Now, because of all this, the impact was really marginal. And one of the things that you would have observed if you were around from 2010 to 2020, if you go to RSA, which is there next week on the show floor, every company will do AI whitewashing. And all the CISOs and buyers would be like completely skeptical. So skepticism was rampant. Now, why was this a case? Vendors don't mean to do bad, right? It's because of three specific reasons. First of all, classical ML AI technology was not generalizable. It's largely supervised learning, which means you have to train it on specific data. And whatever you learn on one task cannot be generalized for the next task. You have to kind of teach it every time, right? Think about it. If you have to specialize in something, then you start from kindergarten and grow up again, right? So that's a problem. This was compounded because data in security, even though there's a lot of data, what you don't have is labeled data. You don't know, especially about attacks, especially about threats. And then economics. Security is massive amount of data. So a single endpoint, which is a laptop or a desktop, your antivirus agent sitting there, generates anywhere between 100 to 300 megs every day. And you have like 10,000 endpoints or 50,000 endpoints in a business over a 90-day period. That's like colossal amount of data, right? All of that has to be managed. Most of the time, the economics were undoable, barring some really large companies like mine, right? So that's why it didn't really work. So let's look at today. I'll show you specific examples. First of all, there are three areas, and Varun, I think, talked about this, and Meera as well. But there are three big areas where security has started to make a difference, or AI has started to make a difference in security. First is threats. We are actually able to detect new novel threats using AI technology. I'll show you an example of that. Second big area is toil. The amount of work security analysts and engineers have to do today is massive. A lot of this is repetitive work, requires domain understanding. We can actually reduce that toil quite significantly. I'll show you examples of features that work, do that work. And third one, what we expect out of an analyst today, even an entry-level security analyst, is nothing short of superhuman. We expect them to understand Linux internals, Windows internals, networking, cloud technologies. Each of these has sub-areas that are worth a PhD. And we expect an entry-level person to be able to resolve issues that require this kind of understanding. That expertise is a big problem, and Gen AI can actually help solve that. I'll show you an example of that as well, right? This is very quickly, what does the architecture today look like? Again, this is something that we delivered today at Google to our customers. At the very foundation layer, you need a platform, that ML AI platform that can really scale, which can take all the data that's there, bring in, run all the ML ops, and so on and so forth. So Google has a Vertex AI platform. That's the foundation layer. On top of that, we have a large language model, which is actually trained on security data, which is SecLM, right? And then we have features that are driven by this Gen AI or LLM platform that service in every product that we offer. So what you see in the green boxes are products we have for security operations, for threat intelligence, and so on, right? So this is the rough architecture today that we offer. So what are some of the examples of capabilities that are tied to the three things that I talked about? Toil, expertise, and threats. This is a natural language search. The video isn't working here, but essentially, when you are investigating an incident or you're hunting for threats in your environment, a usual thing analysts do is to fire a search. The way the search works is that you have to understand the schema of the data. So Google has a format called Unified Data Model, which has 40,000 plus fields. So just knowing that schema is a significant amount of expertise. So crafting that query, think SQL query for a database, a really large data system. It's really hard to do that. And this used to be a problem. But what we have done is actually now simply you can ask the question in standard natural English. In fact, you can do it in any language. That's the beauty. And there's an anecdote here. I was actually in Japan talking to a customer, and they told me, Vijay, I can type the query in Japanese. It translates that into a UDM search query, transparent to the user, and comes back to the results. Phenomenal level of accuracy. This brings down the expertise level that I talked about dramatically down. This is working today, right? Actually, I'll make another point on this after I cover all three. The second one is case investigation summarization. Every time an alert is triaged and you say, hey, this looks like something bad is happening, it goes to a tier 2 or tier 3 analyst. They have to look through all the related events, often thousands or hundreds of thousands of events, try to trace exactly what has happened. That's not easy at all. So what GenAI does is actually it puts it all together, summarizes it, tells you the what, tells you the why, and then also, going back to Mira's point actually, it actually predicts and tells you what you should do, recommends this is the steps that you have to do. This is like a dramatic reduction in toil and dramatic reduction in the level of expertise required. And this is giving benefits today. All this has happened in the last year and a half or so. Okay? Clear value we're delivering. And the last one, this is where I disagree a little bit with what Varun said. And it's not anybody's fault in per se. This technology is moving at such fast pace that none of us can really predict how much we will be able to achieve, right? And this is the case in point. Launched malware analysis using GenAI last year in 2023. And the model that we were using was the state of the art at that time. It could only predict malicious scripts, not binaries, not any other kind of files. And its fidelity was low because LLMs have this idea of a context window, which was relatively small. Any of you who've seen LLMs understand the importance of context window, which simply means how much context does it have? Think about it this way. If you're reading a novel, if you forget what was on the first page, then will you really understand the conclusion, how the story ended? Maybe not, right? So you want to remember everything. Long context windows allow you to do that. So fast forward, this technology, in fact, yesterday we released this. On this long context window latest model, it is doing better than well-trained analysts in terms of malware analysis, and it goes beyond scripts and is able to look at binaries and all kinds of files. Long and short of it is, people who are doing analysis for the longest time, and malware analysis is super hard. You have to reverse engineer these binaries, decompile them, and attackers try to obfuscate the code. So these are super smart PhDs who are trying everything they can to avoid getting detected, right? Now this thing is actually able to manage all of that. Super powerful stuff. So good stuff, but still level 2, level 3 autonomous, okay. So the question is tomorrow, what more can we do? Can we get to L4, L5, right? Yes, but LLMs or Gen AI is not enough. We've got to have post-Gen AI technology, right? And what are the kind of things that you would need? You'd need things like reasoning layers. You would need things like ability to dip into other data sources and so on and so forth. So what does that architecture look like? Remember, I showed you a sec-LM layer, which was just a large language model. But the future architecture, this is what we are doing at Google, we believe is going to be a sec-LM orchestration platform, which has the large language model as a component. So it has two kinds of language models there. A general purpose language model like Gemini, which is there, and also a special language model, which is the security specialized, which is trained on just that data. And I don't know if you caught what I think Varun said, or one of the panelists, but the semantics or simply put, the meaning of security data is very different from natural language. So the SecLM essentially captures the meaning of security data, right? And then you have something called an agent. You will hear this often, mark my words, next 2 years, especially younger people, agents. When you hear LLM agents, these are autonomous software programs that are imbued in large language model understanding, but are able to autonomously navigate, adapt context, dip into different data sources, and then work with one another through that orchestration layer, okay? So think of security as a workflow that comprises many tasks. These agents are specialists in individual tasks, and then they work together. And if you have this visual of small bots trying to work together, that's exactly what it is. This happen to be software programs, okay? This platform enables, this kind of platform architecture will enable those kind of application. So what does this get us? So I think just rooting this back to the autonomous or self-driving car analogy. I think most of you are probably aware of this, but level 1 is simply a stick shift, maybe automatic. But level 2 is where you have assisted driving. It manages lane departure, warnings will come up, or will do adaptive cruise control, look at the car in front of you, adjust the speed based on the distance, right? Semi-autonomous, this is already, in my Tesla, I can start trying it out, where you can hands off the wheel, it drives itself, but you're still there. It's not that I can watch Netflix while that's happening, right? And then autonomous is when I can potentially do that. I can actually sit in the back seat, right? Not worry about it. That's what we want to potentially get. Now, if those are the levels, right, what is the parallel for security? I think it's useful to understand. We were, I would argue, between level 1 and level 2 from 2010 to 2022, okay, or somewhere before that. We are between level 2 tending towards level 3 today with Gen AI technology, right? That's what we're getting. And as we adopt this framework that I talked about, we will be approaching level 4, anywhere between level 3 and level 4. Level 4 is really, really hard to get to, but we will start to get to. It's a spectrum, it's not a discrete thing. We'll start to get there. And level 4 is when you would operate in more of an oversight and override mode, right? That's important for us to control it. And all of this has to absolutely happen because the speed at which, Mira talked about, the speed at which attackers are attacking, it's just not humanly possible to detect and respond. Otherwise we'll be responding, I don't know if you all seen Bollywood Hindi movies, but cops always come after everything is done, right? So the classical technology will just show up after everything is done, right? So it has to be AI-driven. We don't have an option. So yeah, I mean, you can imagine a future, and this is what will happen. We fully expect it. Now, don't ask me by when, because that's a harder question. We'll never drift from an ideal state. Only updates to an org, access policies, that bring, Gemini is our technology, will bring it all back so that the least privileged environment is maintained. Okay? You get notified when it does it, but you don't have to do anything, right? Now today, somebody pointed out rightly, if you look at the stack, it's largely rules-based or heuristics-based. There's not a whole lot of AI. But rules are still pretty good, but you wouldn't have to write any of those. AI will write it, it will keep fine-tuning it, it will keep adapting it, right? You'll have to never investigate noise. Today, most of the time is spent investigating false positives. AI will do that for you. You can fully expect it. It will understand what duplicate issues are, deduplicate all of that, and then eventually just filter up the thing that matters to you. And lastly, there's this notion of playbooks. I think you might have caught that in Mira's talk as well. And Varun also mentioned, I think, security orchestration and response platform source. These are things that manage the workflow, and you write playbooks that are suited to your environment. Now you wouldn't have to write any more playbooks because the investigative playbooks will be triggered and coordinated by AI. And I mentioned the agents there, which actually work together to orchestrate. These will be AI agents that will work together. So that's what it will look like. I mean, I'm going to hazard a guess, and we'll come back after 3 years to see if it's done or not. But I think it's possible. I think in 3 years, we can get close to achieving this, 3 to 5 years. Okay. With that, I'll end my talk. Any questions?